here. When last we were talking on Friday, we were talking about the fact that when you're looking at behavior, often a person's self-report isn't entirely reliable. And the reason that a self-report is not reliable is exactly the same reasons mentioned in chapter 1 of the Moreling book, that our individual reports or explanations for our behaviors may not be actually true. So this is, this study that actually recorded behaviors over the course of time and found that for moms, there's a lot less, for the kids, there's a lot more expressions of how they don't want to eat stuff around the dinner table, and how parents, attempt to use negotiation as a coping strategy for that, and their ratings of the pleasantness of the dining experience go down, mainly because you have kids who are complaining about things. One of the things that's mentioned, that's basically a figure that talks about what's going on. One of the examples that's been presented in research methods classes ever since I took these classes is the Clever Hans, so Kluger Hans example. Now, you might think that this is a picture of someone who's a bit of a charlatan, but actually this gentleman owned a horse, and the horse seemed to demonstrate really amazing behaviors. And if you'd asked Clever Hans, what's 3 + 5, he would clomp his foot 8 times. And you could even have him use the little chalkboard there that to indicate what the answers to various questions were, and Hans seemed to be really, really smart. Now, he was investigated by, I think his guy was Probst at the time, and what was going on there is Clever Hans seemed to be able to pick up on behavioral clues. So it wasn't just this guy running around with his magic trick horse and trying to deceive people. If he was away from his horse and somebody else asked Clever Hans the question, so long as the person asking the question knew the answer, Hans could actually get the answer right. For the heck of it, it should be noted that the guy did not try to make money off the horse, but he did go around taking it out to exhibitions, and they were wildly popular. He didn't charge admission, though. But who needs Clever Hans when in our own life we have Tom the Wonder Dog? If you go to Marshall, Missouri, you will see the memorial garden to Jim the Wonder Dog. And Jim is from 1925 from Louisiana. And Jim was a really, really lazy dog. Jim didn't want to go out hunting. And nonetheless, the guy took the dog out hunting with him and found that Jim was an incredible observational learner. He could watch what the other dogs were doing and respond to the cues. I mean, I don't know if any of you have ever hunted with dogs, but you go out and you whistle or you command, and the dog is supposed to go and get the birds that you've shot, so forth. I myself don't hunt, but I've been on along with people who did. And it gets more interesting than that, because when this little section here says when the owner told him they should rest under a hickory tree, Jim trotted right over to the hickory tree and sat down. And that was really kind of odd. And moreover, if you told the dog to go to a different kind of tree, like an oak tree, the dog would run over to an oak tree. So in much the same way as Clever Hans, this dog had the ability to pick up on behavioral clues that people were giving when you were actually knowing what the answer should be. And you can read this bit as well. I mean, it gets better. Evidently, lots of people wanted to purchase the dog, of course, and it's Supposedly, the dog could also do things like pick the winner of the Kentucky Derby and things like that. But of course, we need to allow for a little bit of Missouri hucksterism there. This has to do with the fact that, when you are assessing, sometimes the moral of the story for psychology is that the assessor can contaminate the results. And for that reason, it's very important to try to control for these effects. We don't have clever Hans, but for example, if we're doing a therapy situation, or you may have read there's a lot of things about mindfulness, if the people doing this mindfulness study have an anticipation that there will be all of these benefits, that you will be calmer, that you will be more centered, that you'll sleep better. When those people are assessing subjects by smiling, by nodding, by communicating, limit someone, by smiling and nodding and by otherwise communicating to people what the answer should be, your subjects could be giving you inaccurate data. So, this is kind of an argument for using internet surveys or using research assistants who are naive to the subject's hypothesis. What are some ways to fix this observer and subject effect problem? Well, mass research is one thing. So if you're using something like a medication, a drug, and neither the person giving the drug nor the participant knows if they're in the placebo or the other group, that helps. You can use unobtrusive observations. Well, what they mean by that is you can use measures that are kind of based on the results of the behavior that happen. What might some examples of that be? Well, every day I go out and I run about 5 or 6 miles, and I run across the road and I carry a trash bag with me, a little trash picker upper thing. Every day I have one full trash bag of beer bottles and soda cans that I pick up. Well, one unobtrusive measure of the area is I could say, if I'm running the same circuit, how many beer bottles, how many beer cans do I see over the course of time? And those little annoying $1 shot things of whiskey, that might be an unobtrusive measure of the amount of alcohol being consumed in the community. Another one that comes to mind that's a little bit gross, but it'll stick in your memory, is sewage. That we can test sewage not only for the effects of COVID-19, as we are doing in our residence halls here on campus now, but we can go down to the community sewage and we can test for the byproducts of alcohol consumption. And you can also test them for pharmaceuticals. So long as people are not flushing pharmaceuticals down the toilet, that will become kind of a good measure of what the community alcohol or drug usage is. Acclimation is another way to try to get rid of observer and subject effects. That's just a fancy word for saying waiting it out until people start behaving the way they do. One way that happens a lot in my work is when we're working with children and you want to have video cameras or you want to have an observer present in the room. For the first couple of weeks, you're just going to be sitting there and the kids will walk up to the observers and interact with them, or they'll constantly turn around in their seats and look at the camera in the corner. But after a while, they forget it's there and they start acting the way that they would normally if there wasn't a camera there, if there wasn't an observer there. You can code tone. That is, rather than looking at individual behaviors, you can develop operational definitions. So in this case, we have coders who are looking at a behavior and looking at verbal and nonverbal markers and rating those on a Likert scale. And that gives us a measure of observation. Down here, just to kind of read through this a little bit, you can see that we've got a data set based on children. And the thing down here that's of interest to you is the inter-rater reliabilities. So you have two raters who are rating emotional tone on a video, and they seem to be having a very high reliability. So the ICC is, for your intents and purposes, the same thing as what's talked about in the book when they talk about coefficient alpha or Cronbach's alpha. It's worth it to mention that there really is no such thing as Cronbach's alpha, because Cronbach did not invent that statistic. That was invented at the University of Minnesota by Cyril Hoyt. And I say that as a vested alumnus of the University of Minnesota. But the ICC, or the reliability coefficient, is a measure of the proportion of variation in the construct, the measure, due to the true score, due to a latent variable representing it, divided by the total variation. So if you see, in this case, an ICC of 0.92, that means 8% of the variation in a person's measure is due to measurement error. Generally speaking, reliabilities higher than 0.9 are really pretty good. If you need some benchmarks, the reliability of the ACTs and SATs that you're taking are around 0.95, 0.96. If you're looking at classroom exams, a good classroom exam probably has a reliability in the 50s to 60s if it's an hour-long measure and it's a multiple choice exam. Generally speaking, the finals that you take that are a couple of hours long, provided the person's doing a good exam, those are running in around the 0.880 range. So down here we have, a picture of the observer watching the interactions going on and doing the ratings through a one-way mirror. That's another way to prevent this reactivity problem of having somebody watching. This is not something that, this slide is not something that is mentioned in the book, but it ties back to the chapter on ethics. Because even when you're doing an observation, you have to think about the ethics. We do an awful lot of work considering the ethics when we're giving out a survey or when we bring people into the lab, but ethics are also important in observation. When do people have a reasonable expectation of privacy? Can you put a camera, a webcam in a bathroom, for example? If you would spin back to earlier research on the sociology and the psychology of pornography, some of these early studies did things like go to pornographic movie houses and watch who parked around them and record their license plate numbers and then match that up with the communities that they came from, not to the person. One of the researchers involved in this study even went to the step, she got in her car and she followed customers of adult theaters back to their homes, and then wrote up saying, well, these homes look to be thus and such SES. Some of these homes have religious statuary around them or patriotic statuary as a way of describing who the customers are. The internet is really quite a huge source of data. So you'll see lots of presentations on analyzing Twitter feeds or Facebook profiles. Consider the ethics of asking for this technological information. One of the studies that we proposed, for example, at Mizzou, involves as step one, do you want to be in our study? We will pay you, but we would like to have access to your phone. Now, the reason they're doing that is your phones very frequently have geolocation on them. So if you study people in looking at their phones, you can figure out when people, this is kind of before COVID, but when people are going out together to a restaurant, how late they stay out, who they are with. And because you can geocode where they are, when they go home eventually, you also know if those people are living in a residence hall together or a fraternity or a sorority. And some of the apps that people use also keep track of where your friends are. So you can record if you have a student who is accessing that, are they then liable to say, well, it's late out here, but I see my friends are over, 2 blocks away at Shakespeare's, so I think I'll go over there. Well, should a researcher be able to have that information? What about access to your computer, to your cookies file? I mean, that keeps track of all of the places you have been. Even if you're doing things like incognito browsing, you can still have cookies stored on your computer. And very frequently, the thing that kind of floors me about this is when you're talking with students, they say, oh, you're going to pay me to be in a study? That's fine. Sure, I'll give you access to my phone. But what if your participants don't realize the gravity of all of the information they're giving? Also, when you're observing, what if you observe a law being broken? Now, as I mentioned before, if you're analyzing things like alcohol, marijuana, drug use, the researcher requests a certificate of confidentiality from the university. And that means that nobody outside the research team can request the data, to get someone into trouble. But on the other hand, what if you uncover abuse? So, if in the course of your observations you see sexual abuse, are you required to report that? And these things sometimes happen. That's part of your consent that, you say, it needs to be in your consent form that these are the things that, we will keep secure, and these are the limitations if we don't. Unfortunately, when people are filling out their consent forms, they often don't read that information. So, I just wanted to have that tie in here because that was one of the holes in the presentation and the chapter, that observation itself is an ethically fraught thing. Any questions on that? So when we are going back to the syllabus, these are, our topics here. Also be able to go in and use those terms. So know what a survey is, what a poll is, what an open-ended question is. One of the things in emailing with students in the class, they said, well, when is something a forced choice question? And I noticed from the slides that the book had, well, they said a forced choice question is a yes or no answer. Actually, you can have forced choice questions that just don't have a midpoint. So if my strongly agree, strongly disagree item has an even number, 1, 2, 3, 4, you have to express that you are either agreeing or disagreeing. It's just a matter of degree. If you have a midpoint on it, you'd say, I'm ambivalent about it. That is not a forced choice question. And as I mentioned before, things like leading questions or double-barreled questions, know those terms, and the various response sets like acquiescence, face-sitting, giving socially desirable responses, faking good or bad, those types of things. All right. Any comments or questions? To some extent, it's kind of good that we hit the next chapter on sampling, because it takes a little bit of time to talk about that. So if there aren't questions about chapter 6, we'll start off with a little bit of chapter 7. Sampling, so The way that this matches with the previous chapter is in the design of your assessment, you need to take care to assess carefully. But who you assess is also really important. And if you're looking at a frequency claim, it's really important that this reflect some type of sample related to a population. Well, just to give an example of excuse me, I had it right here before. Here we go. Here's an example of a frequency claim that's a little bit more topical. So it seems that for young adults, the COVID-19 pandemic is particularly stressful. And one of the issues that this particular study looks at is that the heightened anxiety that they have seems to be related to childhood temperament, the degree of stress that you have. And the National Institutes of Health have these things that are news releases. So you can kind of treat this as a journalistic summary of what's going on. And because the National Institutes of Health are kind of controlling how the information happens, you can actually follow this in a non-jargony way of what's going on. So in this case, they assessed 20% of the students, in their assessment, 20% reported moderate levels, considered to be in the clinical range. Well, that means it's a diagnosis almost. And, these characteristics of childhood things seem to be related to the degree of anxiety that's going on. And I'll provide a link to that in the group when we return. But, it's kind of a nice thing to look at. Some of the hallmarks of looking at this is they will also get you back to the reference to the original work. So if you want, you can log into Alice Library and pull this particular article out and take a look at it. Sometimes it's really important to have that systematic assessment that relates to a known population. Sometimes it's not, though. So in this particular case, we'll be talking about external validity and generalizability in the different ways that you can design a sampling strategy to answer the research questions that you're interested in. Here's a little bit of language, and I don't know to what extent you generally have covered this in your earlier coursework in psychology or in statistics, but we are interested in populations when we're talking about things. And we draw samples that hopefully reflect some kind of populations. And a key consideration here is the issue of bias. So if, for example, some types of people in the population are more or less likely to be willing to participate in your study, your means, your correlation coefficients, and your statistics will to some extent not be entirely accurate. And there are different ways to go out and get a representative sample. And we'll be talking about particular strategies. Sometimes, for example, and we'll get into the details more on it, you just want to say, here is my population. I am going to broadcast an invitation to it and see who participates and try to keep track of who does and doesn't participate in terms of characteristics, and hopefully get a sample of people who are roughly representative. And other times, if you have some more data about the population, you might try some type of probability sampling. As you might say, for example, I know that our population consists of a certain proportion of white students, of Black students, Hispanics, and Asian Americans. And Therefore, I'm going to go out and try to sample enough people so that the people who are eventually end up in my study roughly represent those proportions. Sometimes you might even offer slightly different incentives to people to participate, given that some populations, we mentioned, for example, that Black participants might be a little more hesitant to participate. Lower SES participants are a little more hesitant to participate. And for that reason, you might offer slightly different incentives, at which point you need to think about those incentives carefully and ask yourself whether this borders on coercion. But you can sample to that population in a targeted fashion. You might also try to sample so that you get exactly the proportions, and we'll be talking about those techniques as well. Other times, you might want an unrepresentative sample, and you might use biased sampling techniques. And even those terms have, kind of some negative connotations to it. There are some situations where you actually want an unrepresentative sample in order to do your study. So here's a slide for our terms. Population is the set that you want to be, set of people that you're interested in. The sample is a subset. A census means that you are assessing all individuals in the sample. So for example, a few years ago, I believe it was like 2007, we did a census of all freshman students at Missouri in terms of their alcohol use and college experiences. In which case, that becomes the target population that you're interested in. This leads to the question of what's the population of interest? At what point do we say, we did a census, these are the facts, ma'am, and we're done? And at what other points are we saying, even though this is a large number of people, and perhaps even all of the people at a given institution, are we going to be generalizing to other populations? So if you do a sample of everybody at the University of Missouri, on the one hand, you can say, well, here's a portrait of Missouri, but actually that census is representative as a sample of some larger population of, say, all college students at Midwestern universities, or maybe the University of Missouri next year or in following years. So here are some examples of biased samples and representative samples. So if you're interested in, for example, this is just straight out of the book, population of Democrats in Texas, if you recruit people sitting in the front row at the state Democratic convention, that's going to be a biased sample. We know that's going to be biased in a couple of ways because the convention organizers are going to make sure, for example, that the people sitting in the front row are going to be ethnically diverse, and diverse in terms of their ages, and diverse in terms of their sexes, regardless of the fact that those populations are probably not that equally balanced in the population of all Democrats in Texas. An unbiased sampling technique is to go and get a list of all registered Texas Democrats and then call a sample of them through random digit dialing or by contacting them on the internet. So this unbiased sampling technique is likely not to have the ethnic, age, and sex biases that are present in just looking at the sampling technique that you have. Second example, looking at drivers. You can stop people who are putting money in the parking meter and say, here's my survey, do you think you'd like to take this? That's going to be relatively biased. I mean, it'll be people who are shopping downtown, for example, at a given point in time. It's a better idea to get a list of licensed drivers in the state and then get a sample of that using maybe a random number generator or digit dialing. And this last one is perhaps nearest and dearest to my heart. People who have taken a class from a given professor. Well, a biased sample is looking at only the written comments on a website, like ratemyprofessor.com. But if you got a list of everybody who had that person as students and selected every 15th student, that's going to be an unbiased sample. Now, what are some ways that, given the book that they're talking about here, they're saying this is an unbiased sampling technique. How is even that sample going to be biased? See if I've got some comments coming on. Nope. Hello. So let me lead it a bit. If I go through everybody who has completed the course with the professor and I contact every 15th student, how might that sample be biased?
The students who have finished your course don't have to worry about you hearing their responses, whereas the current students do.
Yeah, so there's a power differential there. Does everybody who signs up for the class on the first day end up completing that class with that professor?
No.
No. So if, for example, and I've known a few people, unfortunately, in statistics departments who teach this way, the first few weeks of class are absolutely hellacious. And everybody who can drops. And then the person says, okay, folks, now that we've got the riffraff out of the way, now let's get down to teaching you in class. Well, that sample is incredibly biased. So even in this situation, this sampling technique might not give you the population that you think you have. So I'll keep the chat box open here. So if I ask questions, I get some answers. One way a sample can be biased is with convenience sampling. And, I guess to some extent, the Psych 1 pool is often a convenience sample. We've also done, Amazon's Mechanical Turk or Prolific. If you've ever signed up for that, it's a way to make a little bit of spare money if you're interested. Prolific pays a lot better than Mechanical Turk. But the people who sign up for doing these types of things are probably a little bit different than a general population. So you need to think a little bit about asking questions that ascertain basic demographics like age, race, or sex, and the state that you live in, for example, to try to get an idea of whether this sample is going to relate to the population that you were interested in. So on the one hand, especially on the internet, a lot of the samples and the research that you see going on may be quite biased. If you log on to msn.com, for example, you'll see a little survey of the day with some response options in it. Well, probably just from looking at the results of those things over the course of time, I think that the people who are answering those questions are probably older people and more conservative people. But you have no idea what population you're actually generalizing these people to. On the other hand, there are some situations where there are things that are being gathered in the population that seem to be relatively carefully drawn samples. So in this particular example, they're talking about an online survey on road rage. They were randomly sampled and invited to respond. So you can probably think that that particular internet survey is more of a random sample than just some random button that you see on a web page that you visit. So here's some words. Now, when you want to have external validity, you're going to need to have a representative sample. And one way to accomplish that is to use probability sampling, in which every individual of interest in the population of interest has an equal chance of being selected. Simple random sampling is just that. You put everybody in a pool and you select a predetermined number of people from that to participate. Another way to get simple random sampling is to give everybody a number and use a table of random numbers to select the sample. Random sampling can be really difficult to do and time consuming. If it's not possible to enumerate your population of interest, you're going to have to use some kind of a variation on that. So here's some ways of looking at that. Systematic sampling, cluster sampling, multi-stage, stratified, and oversampling. So if we go back to our syllabus, these are terms that you're going to need to know. Systematic sampling is, for example, I roll 2 dice. If one lands on a 5 and the other lands on a 3, I'm going to start at the 5th person in the class and choose every 3rd person until I get the desired sample. Cluster sampling says there are clusters of participants inside the population that are randomly selected, and then all individuals inside that cluster are used. This is used a lot in education. So I might, for example, say, I've got schools in the city of Columbia. I'm going to pick one classroom from each of the schools in Columbia. Sorry, one school from each of the schools in the school system. And then inside of that, I'm going to pick a class at random. But inside that classroom, I'm going to select all of the individuals inside that. So in this way, it makes sense to do this because I've got all of the people inside the classroom. Those classroom effects become something I can analyze. And logistically, it might not be feasible to say, I want to have 5 individuals from this classroom and 6 individuals from that classroom, because going in and actually scheduling the assessment is quite difficult. And, you don't want to have to pull students out of class, but it is easier to get an entire classroom students who have been selected at random from the school to all participate, because you just say, I want next Tuesday at 2 o'clock in the afternoon for my study. So that's cluster sampling. Is that okay as to how that's different than systematic? Maybe one strategy is to go through and do all of these and then talk about how they're the same and how they're different. In multi-stage sampling, I'm going to be taking 2 random samples. A random sample of clusters is picked from your population. And then in stage 2, I'm now going to do a random sample of people. So if I start with a list of high schools in the state, I could select 100 of those schools. But instead of selecting all the students, I'm going to select a random sample of students inside those 100 selected schools. So that's different from cluster, where I'm going to pick a classroom at random, but I'm going to assess everybody inside that classroom. Stratified random sampling is slightly more complicated, because what I'm going to do is to select some demographic characteristics, race or age or gender. And then inside of that, I'm going to make sure that I sample all of the people in that group so that my end sample has a proportion that is representative of the population of interest. So at the end of the day, you can say this stratified random sample has demographic characteristics that reflect exactly the population of interest. So if you're doing survey methodology, stratified random sampling is quite frequently the weapon of choice. For things like 538.com, if you follow, that's a website that does predictions of the elections that happen. Because at that point, you know that the survey that you're doing actually looks like the population that you're interested in, which might be all individuals who are likely to vote. It's important to kind of draw that distinction. People in survey methodology are not interested in reflecting the population, because many of our states, for example, are horrifically gerrymandered, or many of them have active voter suppression efforts. So even though, for example, in the state of Missouri, there are a lot more Democrats in the state than you would think based on the composition of the legislature, taking into account who the likely voters are, who is able to vote, and the composition of our districts gives us a stratified random sample that allows us to predict more accurately. For example, if you want to go from one end of the legislative district of the city of Columbia to the other, you will have to take about a 2-hour trip. This is just an example of gerrymandering. You have to start it in Columbia, then you'll have to go on I-70, go across the Missouri River, get off at that exit, go back down through Prairie Home, head south in order to get to the other very, very rural part of the Columbia district. And before you then re-enter the county, it's not possible to navigate from one end to the other. So if you're trying to forecast what's going on, this is why we have Blaine and Utkemeyer as our representative. That's, you need to sample from that rather esoterically drawn gerrymandered district. And then oversampling. So this is a variation on stratified random sampling, but you want to be sure to overrepresent some of your groups. So in this particular case, maybe your population of interest has a low percentage of South Asians, because 40 individuals, this over so I can read this, 40 individuals are not enough to make statistical estimates. Instead of only 40 individuals, you're going to sample 100 more of them. So the need to do oversampling is because you are interested not only in getting a population estimate, but you're trying to use your statistics to find a statistically significant difference. This happens a lot in the work that I do when we're looking at psychopathology. So eating disorders or phobias or psychotic breaks are fairly rare events. But if you want to make a conclusion from your study to do comparisons as to how, say, young women who have eating disorders are different from young women who don't, you're going to have to oversample that target population. Okay. So, those are 4 ways that we draw a representative sample that are not entirely random sampling. Any questions on that? Okay. It's also possible to take these techniques and combine them. So this is kind of a nice little figure. As we look at our population of interest, this down so I can make it bigger, there are non-probability sampling ways. So we'll talk more about the non-probability ones, but I can do a purposive sample, a snowball sample, we'll talk about that later, a quota sample and a convenience sample. But over here, I've got probability sampling where I've got a simple random sample, just picking people randomly out of the known population, oversampling, systematic sampling, cluster, and stratified. But sometimes when you're doing these studies, you can take techniques from the left-hand side and combine them with techniques from the right-hand side. What are the advantages and disadvantages? This is a little bit of, and this is a semantic thing, it's a word thing. How is random sampling different from random assignment? In random sampling, I'm trying to draw a sample and then go back to my population. In random assignment, I have an experimental design and I am assigning participants to their groups at random. So in the case of random sampling, I'm going to have better external validity. That is, I'm going to have more confidence that this generalizes to a population. In random assignment, I increase internal validity because I know that there was no other characteristic of the population that could have affected which group people ended up in. And because they were randomly assigned, I'm more confident in looking at statements of causality in the variables that I'm looking at. Sometimes we're going to be looking at an unrepresentative sample. Convenience sampling, purposive sampling, snowball sampling, and quota sampling. So let's go through these in order. Convenience sampling is a pretty easy thing. That is, I go out, I find some people, period. I don't have any really good idea as to what population this convenience sample generalizes to. Convenience sampling is also a fancy way of saying, I don't really know what my population is. Knowing what your population is referred to as a sampling frame. And if you're doing survey research, or if you're doing political polling, knowing the characteristics of your population, knowing a list of the names of people and what their characteristics are is kind of step one. When you don't have that, you have convenience sampling. Purposive sampling is looking at samples of individuals who have a given characteristic. And again, I don't have a really good idea of what my sampling frame is, but I do know that I want to look at some characteristics of that. For example, if you're walking down the street in Columbia and you walk past a kiosk and they say, we are seeking individuals who are within a certain age range and who are regular marijuana users, that's a purposive sample. We don't really have a clear idea of what the population of people are who are walking past the kiosk, but our study is interested in looking at marijuana users. Kind of the same thing involves when we're looking at alcohol research as well. Snowball sampling is an interesting variant on that. And honestly, folks, I'm not quite sure how I feel about it. But if you're looking at someone who has a condition, very frequently those people know other people who have that condition. So, for example, my younger sister has multiple sclerosis. And it's kind of interesting to me that she tends to know lots and lots of people who have multiple sclerosis. And because of HIPAA, you as a researcher might have a really rough time identifying a target population of people with MS. So once you have found a participant who has this disorder, you can then say, do you know some other people who have this? And you can then start to recruit those people. And in that way, you can get a number of people who have the condition. So snowball sampling is kind of purposive sampling, but you're using the social network of the person, of one participant, to build your purposive sample. And as I said, that's kind of mostly of use when you're looking at a rare disorder. Okay, I see that I'm running us a little bit over time today. We'll put a pin in that today.